When you're in the kitchen watching chocolate melt or a pot of water boil, have you ever stopped and wondered what's actually going on there? Well, it turns out your kitchen is a pretty amazing science lab. So today, we're going to uncover the incredible science behind how things change.
So let's start with this. On the one hand, you've got melting chocolate. On the other, a bubbling pot of coconut milk. They seem totally different, right? But, believe it or not, they are showcasing the exact same fundamental scientific idea. Let's dive in and see what it is.
And it all begins right here, in a place we all know. The kitchen is where we can see the science of transformation happening pretty much every single day. Okay, so that transformation, like seeing a solid block of frozen coconut turn into a creamy liquid, that's not just cooking. It's a process that scientists call a change of state. It's really just the journey a substance takes from being a solid, to a liquid, to a gas, or even back again. The first one, the one we all know, is melting. As that solid coconut sits in a warm pan, it's just sucking up heat energy from its surroundings. That energy gets its tiny particles moving more freely, and boom, it turns into a liquid. The key thing to remember here is that melting is all about absorbing energy. Now, these changes of state aren't just a one-way street. They happen when we add heat, sure, but they also happen when we take it away. So if we keep heating up that coconut milk, what do we see? Bubbles. That's boiling. The particles inside are getting so much energy that they literally break free from the liquid and escape as a gas, which is what we see as steam. Oh, this is a really important point. Boiling is fast, right? It's intense, it happens at a specific hot temperature, but evaporation, that's the slow and steady version. A puddle disappears on a cool day, not because it's boiling, but just because its particles are slowly escaping into the air over a long time. And this slide just lays out the whole cycle perfectly. Heating things up gives us melting and boiling, but if we cool things down, the whole process just goes in reverse. A gas will condense back into a liquid, and a liquid will freeze back into a solid. It's a perfect loop. So we've said the word energy a few times now, but let's really get into it, because energy is the secret ingredient that drives every single one of these changes. Let's go back to Keisha's dad making that birthday cake. To get that perfectly smooth, melted chocolate, he has to heat it up. What's really happening is that the solid chocolate bar is literally pulling heat energy out of the warm pan to make that change happen.
And of course, there's a scientific name for that. It's called an endothermic process. Any change that needs to absorb or take in energy from the world around it, that's endothermic. And melting is a classic example.
But what happens when that melted chocolate gets poured on the cake and starts to harden? Well, it's the exact opposite. It starts releasing all that stored up heat energy back into the air. That is an exothermic process, when energy exits the substance. And here is a fantastic way to remember this. Endo sounds a lot like into, because energy is going into the substance. And exo sounds just like exit, because energy is exiting the substance. Simple, right? I love that. So we've looked at the big picture, the stuff we can see. But now let's zoom in, way in, to see what's going on at a microscopic level, because it is all about the particles. So here's the mind-blowing idea. Everything around us, the screen you're looking at, the water you drink, the air you're breathing, it's all made of these incredibly tiny particles that are constantly moving. And how they're arranged and how they move determines, well, everything. So, in a solid like that block of frozen coconut, the particles are locked into this really neat, tight formation. They still have some energy, so they're not perfectly still. They just kind of vibrate in place. But when we add heat and the solid melts, those particles get a huge boost. They're still packed pretty close together, but now they have enough energy to break out of that rigid structure and start sliding past one another. And that is what gives a liquid its ability to flow. And if we add even more energy and it starts to boil, the particles go absolutely wild. They get so much energy that they completely break away from each other and just start flying around randomly, filling up whatever space they're in. And that's a gas. Okay, we've got the theory down, we understand states, we get energy, and we know about particles. So for the fun part, let's put it all together and do something really cool. All right, so here's a little challenge for you. Based on everything we've just learned about how energy moves around, how in the world could you take liquid milk and turn it into solid ice cream without a freezer?
Well, the answer is surprisingly simple. You just pour your milk into a small bag and seal it up. Then you put that bag inside a bigger bag that's filled with ice and a secret ingredient, salt. Put on some gloves and just shake it for about 5 minutes, and that's it. Instant ice cream.
So what's the science? This is where it all comes together. The salt forces the ice to start melting at a much colder temperature than normal. Now, remember what we said. Melting is an endothermic process. It needs to absorb a lot of heat. And where does it get that heat from? It yanks it right out of the bag of milk, making the milk get so cold, so fast that it freezes solid. So when you boil it all down, that's the whole story. From a puddle evaporating on the sidewalk to chocolate hardening on a cake, every single change of state we see is just a tale of tiny particles either gaining or losing their energy. And that's our explainer. Now that you see the world as this incredible dance of particles and energy, what transformations are you going to notice today? A foggy mirror after a hot shower? Frost on your window in the winter? The science is absolutely everywhere.